Hey physics babies, welcome to Pandemic Education, episode 5. Today we're going to talk about electric fields. We're going to learn another way of calculating the magnitude of an electric field. So please make sure you've got a calculator, make sure you've got your formula sheet, and let's get into it. Okay, so we're going to do a little bit of a different setup today. I'm actually going to take notes, and I'm going to ask that you follow along in your notebook. Hopefully you have a notebook. If you don't, follow along on some scratch paper and make sure you've got a formula sheet out to add to today. So this is lesson 5 in our pandemic education series, but specifically we're doing unit 5 lesson, I'm calling it 2.5 because lesson 2 was electric fields and today is electric fields continued. So last class we learned that an electric field is an invisible property of a charged object that shows the electric force and allows it to do work on other charged objects. Remember, electric fields point towards negative charges and away from positive charges. Last class we learned this formula, E equals F little e over Q naught. All right. E was that magnitude of the electric field. And we use newtons per coulomb as our units. F little e was the electric force. And we use newtons for that. And then Q sub naught is the charge of the particle. And we use coulombs to measure that. Well, we're not always going to be given the electric force. So there's another formula that we're going to talk about today, and that is E equals KQ over D squared. This formula gives us the same end result. We are still finding the magnitude of our electric field. And it's still measured in newtons per coulomb. But in this problem, K is our coulomb's constant, which is 8.99 times 10 to the 9th Newton meters squared over coulomb squared. Q is still the charge of the particle. And we measure that in coulombs. Oops. And then D, oh, sorry about that. Let's try. Let's try this. D is our distance between the particle and the object. And we measure distance in meters. So, depending on what a problem gives us, we can either use this formula right here or this formula right here. It's kind of like how we have multiple formulas to find the acceleration of an object. Depending on what we're given, we pick a formula and we plug it in to solve. So, let's get some practice. We are looking at this first problem from our lovely textbook that I know you've never actually looked at, probably never even noticed, sitting in the back of our classroom. It says, what is the magnitude of the electric field at a point that is 0.3 meters to the right of a small sphere with a net charge of negative 4.0 times 10 to the negative 6 coulombs. So, step 1, hold on, is to write out our givens. So, I'm going to take a second and write all those down. Example 1. We were given that there is a charge of negative 4 times 10 to the negative 6 coulombs. We were given a distance of 0.30 meters. I'm just going to rewrite that. That looks like trash. Sorry about that. And we know we want the electric field. So, I'm actually going to take a second and draw this out because this problem was a little bit specific, and it said that we've got a charged object, and then to the right is the charge that we're asking about. So, my charged object has a charge of negative 4.0 times 10 to the negative 6 coulombs. And this is our Q. And this is, we're trying to figure out what the magnitude is right here at this point. So, based on my givens, I've got a D, I've got a Q, and I want E. Which formula should we pick, 1 or 2? We should pick formula 2, right? K is a constant. We always know what K is. And I know these other two pieces. So, let's go for it. E equals K Q over D squared. Filling in what we know, K is 8.99 times 10 to the 9th times Q is negative 4.0 times 10 to the negative 6 divided by D, which is 0.30 squared. All right, turning to our handy-dandy calculator. We're going to tippy-tappy-typey 8.99 times 10 to the 9th times negative 4.0 times 10 to the negative 6 divided by 0.3 squared. Whew, that's a big old number. Let's take it right now and round it to 3 sig figs. I see, start from the left, 1, 2, 3. We look at that fourth number. It's a 5, so that means I need to round this 9 up. Well, rounding that 9 up gives a point over here. Okay, that makes this round up. I'm going to call this negative 400,000. My units for magnitude of an electric field is newtons per coulomb. So now let's talk about this negative sign. This negative sign does not mean that the value of the electric field is negative. This negative sign is telling us direction. Okay? So, if it's a negative sign, is that to the right or to the left? It's to the left, guys. But we also can just say that our electric field is equal to 400,000 newtons per coulomb towards the negative charge. And if we're being honest, I think this is the easiest way to put it, because that will help us to remember that electric field lines always point towards the negative charge and away from the positive charge. But we'll also add in here that's to the left for this problem specifically. Okay, we're going to do one more example together and then we'll be done. So, the next problem asks us, we're looking at number 8, what is the magnitude of the electric field at a position that is 1.2 meters from a 4.2 times 10 to the negative 6 coulomb point charge? So, example 2, my givens, let's list them out. My distance is 1.2 meters. My charge is 4.2 times 10 to the negative 6 coulombs. And I want the electric field, the magnitude of the electric field. Well, thinking back to the two formulas that we have, we're going to use the new one, the one we just learned today. E equals K Q over D squared. K, remember, is a constant. We know it. It's always 8.99 times 10 to the 9th. So let's fill in what we know. times my charge, which is 4.2 times 10 to the negative 6, all divided by 1.2 squared. Heading back to our calculator, 8.99 times 10 to the 9th times 4.2 times 10 to the negative 6 divided by 1.2 squared. 26220. Alright, so let's write that down. Newtons per coulomb. Let's take this and try practicing rounding it to 3 sig figs. So this is 1, 2, 3. We look at our fourth value. It's a 2. So instead of taking it and rounding this one up, I'm going to drop it down to 0. And there's my final answer. So that's it for today's lesson. There's just a short assessment that's got 2 problems on it. Do your best. Do great things. The answer will pop up as soon as you hit submit on it. Just take a second and double check your answers. If you don't type your answer in exactly the way I type it in, it's going to mark it wrong. If what you wrote and what I write are the same thing, don't even worry about it, okay? I am looking at everyone's individual answer choices to say, hey, yes, you got this problem right, or, oh, you actually missed something and got the problem wrong. So if you're saying the same thing I'm saying, don't worry about it. And that's it. Feel free to send me an email with any questions. Keep coming to office hours. I think it can be really helpful if you show up. Also, I miss you and would love to hear your voices. That's it. Love you lots. Do great things. Bye.